Hey everyone! Today we'll be taking a look at how a Gauss rifle works. Construction begins with a flat surface, typically a ruler, but dowels would be preferable. We can begin by taping or gluing some magnets onto the pair of dowels. Next, we place two spherical ball bearings onto the back ends of each magnet. Now, our rifle is ready to use. Just take another ball bearing and place it at the front end of the apparatus, giving it no more than just a small nudge to get it rolling. As you can see, the ball will roll down, speeding up and launching off the end.
Alright guys, so here's our ruler, or a pair of dowels. We have our two magnets. There are two ball bearings on the back side of each magnet. Alright, so that's our setup. Now, we place another ball bearing at the front end, right? Let's call that the front. And we give it just enough force to start rolling. And right now, the factors at play are air friction and rolling friction. However, given that we're using very smooth ball bearings and our dowels are very smooth, these two things are negligible. We can forget about them. Right, so the ball is rolling down the dowels and it gets closer to the magnet. And what happens is the magnet will induce a dipole moment on the electrons inside the ball bearing. And once you have enough aligned dipoles, you'll have a magnetic attraction between the ball bearing and the magnet. And when that happens, you have magnetic force, which we know due to Newton's second law is equal to ma. And so what this means is that the ball will start accelerating. And as it accelerates, it picks up speed. Right, so it gets closer and closer, and eventually it hits the magnet. So what happens is you have a conservation of momentum, right? Initial momentum equals final momentum. Right, so you have a transference of momentum to the magnet. That momentum goes through to the first ball. Now, because this ball is so close to the magnet, you have such a great magnetic force that the ball can't actually move. So what happens is that the momentum is instead transferred to the second ball, and then this ball will start moving. And because momentum is equal to mv, and the balls are identical with the same exact mass, the second ball bearing will start moving with the same exact velocity. As it gets closer, the same thing happens with this magnet. It induces a dipole moment on the electrons, causing the ball to accelerate, picks up speed, then it hits, momentum is transferred through to the last ball, which has an even greater velocity, v prime. And then that will fly off the edge of the ruler or the dowels.
I'm going to show you how to build an actual model of the Gaussian rifle. Right, so you can normally use a ruler, but we're instead choosing to use two dowels because it creates a divot. It makes it easier for the balls to roll down. Right, so you're going to take two dowels and you're going to glue them together. Alright, so after waiting a few minutes for the glue to dry, make sure you flip the dowels over to the other side, the dry side. Now we're going to glue the magnets on.
So now we're taking the ball bearings and we're putting them onto the Gauss rifle.
Now it's ready for use.
And there you have your Gauss rifle.
CEO teaches you 3 things.
Okay.
Bloopers. Hey guys, I'm going to show you how to build an actual model of the Gaussian rifle. Right, so you can normally use a ruler, but we're instead choosing to use 2 dowels because it creates a divot. It makes it easier for the balls to roll in. Right, so you're going to take 2 dowels and you're going to glue them together.
Are you recording?
Sorry?
Yeah.
So here, we have a ruler or a dowel.
Wait.
We can just like fast forward. Or maybe we should just leave it and have the run.
You want to hold it together?
Apply pressure for even.
I like strong, dark hands on my dowels.
Alright.
And now we wait for it to dry.
Yeah, you don't want to start putting things on there when it's still wet, otherwise it'll fall apart.
Crazy glue is very sticky. It bonds the skin instantly. Don't be like us.
Please, don't do this. Don't give us that.